Hello everyone, my name is NEERJA ARORA and I am working as an assistant professor in CSC department at AKGEC Engineering College, Ghaziabad. So today I am going to discuss one of the sorting algorithm, that is quick sort, which comes under the subject design and analysis of algorithm having code KCS 503. So today I am going to discuss these topics, that is what is sorting, various sorting algorithms available to sort the elements of the given array. Then we will also discuss, or we will focus on the quick sort algorithm, its overview and the technique or concept which we follow to sort the elements of given array using the quick sort algorithm. Then after that we will also analyze the time complexity or running time, basically the time the quick sort algorithm takes to sort the given elements. And at the end we will also discuss the various pros and cons of the quick sort algorithm. So what is sorting? Sorting means basically arranging the elements of an array so that they are placed in some relevant order, which may be either increasing order or decreasing order. So if you are having the A, which is an array, and the elements of an array are arranged in a sorted order in such a way that A0 should be less than A1 and A1 is less than A2 and so on. Basically it is a ascending order. You may also arrange the elements of the array in descending order, that is A0 is greater than A1 and A1 is greater than A2 and so on. So if you are given array A and having elements unsorted way, in an unsorted way, that is 21, 34, 11, 9, 1, 0 and 22, it means you are given integer unsorted elements, and by using the sorting algorithms or sorting technique, you can arrange these elements in sorted order, either in ascending order or descending order. So what is sorting algorithm? Algorithm, we all know that it is basically a set of instructions that you have to execute in particular sequence in a certain order so that your given task will be completed. Or so sorting algorithm is basically, it is also an algorithm that puts the elements of a list or a given array in a certain order, which may be either numerical order, lexicographical order, or any user defined order. So we are having two types of sorting. One is internal sorting and another is external sorting. We will use the internal sorting algorithm when your data is stored in your internal computer memory. Okay, basically it deals with the sorting the data stored in computer's internal memory. But if we are having the data stored in our external files, then we have to use the external sorting. So external sorting basically deals with sorting the data which are stored in files, and this is applied when there is a voluminous or huge amount of data that cannot be stored in your internal memory. These are the few algorithms, sorting algorithm, that we can use to sort the elements of the array. We are having bubble sort, insertion sort, selection sort, merge sort, quick sort and heap sort. But in today's lecture we will discuss about the quick sort algorithm. So basically the quick sort algorithm is a highly efficient sorting algorithm which is faster than other sorting algorithms which are having time complexity big O and log n, like merge sort. Merge sort is having time complexity big O and log n. So quick sort is more efficient and faster as compared to these algorithms which are having big O and log n time complexity. So like merge sort, this quick sort algorithm also works by using divide and conquer strategy. Firstly, we divide the given large unsorted array into two smaller sub arrays. Then we recursively sort the elements of the two sub arrays using the pivot element or key element. This is the main key point of the quick sort algorithm. Quick sort algorithm is totally based upon the pivot element. We have to randomly choose any one element as a pivot element or key element, and with the help of that pivot element we sort the elements of the given array. Also, the quick sort is in place sorting algorithm. In place means we do not need any additional space to sort the elements. We sort the elements at their original memory location, at their original space. We do not need any additional space or external memory to sort the elements. That's why it is known as in place sorting algorithm. This is a work strategy of the quick sort algorithm. Firstly, we have to select the pivot element from the array elements. You can choose any element as the pivot element. Either it is a first element or last element or in between any element. You have to choose any one element or pick up the any one element as the pivot. Then after choosing the pivot element, you have to rearrange the elements in the array in such a way that the elements which are less than the pivot element will appear before the pivot element position, and the elements whose value is greater than the pivot, they will come after the pivot element. But if one element which is equal to the pivot element, if its value is equal to the pivot element, then it can go either way, either in the left subarray or right subarray. So basically, this is a partitioning. So after such a partitioning, the pivot will be placed at its final correct position, and this is known as the partition operation. And after our partition operation, we will get the two subarrays. One left subarray which is having the elements which are smaller than the pivot element, and the other subarray is having the elements which have the higher value as compared to the pivot. And we have to recursively sort these two subarrays obtained. That's why quick sort algorithm is also known as partition exchange sort algorithm, because it is totally based upon the partitioning of the given array with the help of pivot element. So quick sort algorithm, like other sorting algorithm, works in number of iterations in passes, and after each iteration or pass, one element is will be reached at its correct position. So after each iteration, the pivot element will be reached at its correct position. So with every iteration, there is one element less to be sorted in the array. That means in the first iteration, the size of the array will be n. In the second iteration, size of the array will be n-1 and -2 and so on. So after every iteration, the size of the array will be reduced by 1, because after every iteration, the pivot element will be reached at its correct position. Okay. So the main task of the quick sort is we have to find the pivot elements and its right position, which will partition the array into two subhalves. So basically, this is a technique or steps that you have to follow in quick sort. First, suppose this is a given array. We are having 1, 2, 3, 4, 5, 6 elements which are in unsorted way, and we have to sort these elements in suppose ascending order. So we have to choose 3 variables. First is a left variable and another is a right variable. So we have to initialize the left variable at index 0. So first element is 27 and its index value is 0. So we initialize this variable left as 0. So left is pointing the first element 27 and the variable right will point the last element 45, and it is initialized with n-1, okay, last index value. After initializing left and right variable, we also choose the pivot element. Okay, we have to choose any one element as the pivot. So suppose in this example, I have chosen the element 27 as the pivot. Okay, so I have chosen the first element 27 as the pivot or key element. So I have used one variable LOC which pointing to the pivot. Okay, so pivot is a 27, so the variable LOC will be initialized with 0. So LOC will point to the pivot element 27. So this is the first step, and after initializing these variable LOC left and right, we have to start from the element pointed by the right and scan the array from right to left, comparing each element on the way with the element pointed by the variable LOC. One thing you have to remember in quicksort is that you always have to move towards the pivot element. If pivot is at the left position, then you have to scan the array elements from right to left. Okay, but if the pivot element is at the right position, then you have to move towards the right direction from left to right. So this you have to remember. Okay, so here in this case the pivot is at the left position, then you have to move or compare or process the elements from right to left one by one. So if pivot is at the left and you are moving from right to left direction, then you have to compare A LOC and A right. You have to compare A right element and rightmost element with value of the pivot. Okay, if A LOC matlab pivot element is less than A right, that is 45, then you have to simply move towards the left. You have to decrement the right variable. Okay, so in this case, if A LOC is less than A right, then you have to simply continue comparing until right becomes equal to LOC. जब तक आपका right variable LOC तक नहीं आ जाएगा, तब तक आप क्या करते रहेंगे? Decrement. Okay, so once right is equal to LOC, it means pivot has been placed at its correct position. But in between, if at any point A LOC is greater than A right, okay, if pivot element is somehow greater than the A right element. So suppose in this example, if I have compared 27 and 45, so 27, that is A LOC is less than A right. So simply we have to decrement the right variable. Now we have to compare 27 and 25. So in this case, A LOC is greater than A right, but we have to arrange the elements in ascending order. So here the value should be less than this value, but in this time, at this time, 27 is greater than 25. So we have to interchange these two elements. Okay, if A LOC is greater than A right, then we have to interchange these values and move to the step 4. Okay, step 4 अभी हम discuss करेंगे. So, and also you have to make the LOC equal to right. Now, if we interchange these two elements, then 27 will be here. So LOC will also point to now at this index where the pivot element is present. So if 27 is here, then LOC will be equal to index value of this position. Example के साथ अभी हम इसको clearly करेंगे. But and this is a step 4. As if A LOC is greater than A right, then we have to interchange the values and we have to move to the step 4. So this is the step 4. So what we are doing in step 4? In step 4, we have to start from the element pointed by the left and scan the array from the left to right, comparing each element on the way with the element pointed by the LOC. Basically, step 4 is executed when A LOC at the right position and we have to move from left to right. Okay. So in the previous step, we have interchanged the 25 and 27 and LOC comes at this point. So now we have to move from left to right. We first compare 25 and 27. It is in sorted order. So we simply move towards the right. It means we have to just increment the left variable. Okay. Now left variable is pointing the value 10 and A LOC is 27. Now 10 is less than 27, then we simply increment the left. But now here the value is 27 and here the value is 36 and here the value is 27. So this is wrong. Our condition is not matching, because in step 4 the ALOC should be greater than A left, but here the A left is greater than ALOC. So what we have to do? We have to just interchange these two elements. Okay, if ALOC is less than A left, that is 27 is less than 36, then we have to interchange these two elements and also set the LOC is equal to left. क्यों? Because अगर हम 36 and 27 को interchange करते हैं तो now LOC will be this. LOC अब आपका यहाँ आ जाएगा, क्योंकि 27 इधर आया तो LOC will be also shifted to this position. Okay, now set the LOC equal to left. Example के साथ इसको करते हैं तो more clear it will be more clear. So this is the example. We are having 6 elements in unsorted way. So in the first step we have initialized the variable. Left is pointing to the leftmost element, that is 27. The right variable is pointing to the rightmost element or last element of the array, that is 45. And we have chosen the pivot element or key element, the first element, that is 27. So LOC is also pointing to 27. So LOC is at the left. So our direction of comparing will be from right to left. Okay. So first we have to compare 27 and 45. They are in sorted order. They are already in ascending order. So no need to interchange. We simply decrement the right variable. We just move towards the left, towards the pivot element. So now at this point we have to compare 27 and 25. So here ALOC, that is 27, is greater than A, right? They are not in sorted order. So we have to interchange these two elements. So after interchanging 27 and 25, 25 will be here and 27 will be here. And we have chosen the 27 as a pivot element. That's why LOC will be interchanged. So in the previous step LOC is here, but after interchanging these two, LOC will point at this position. Okay. Now LOC is at the right. So we have to move towards left to right. So now we have to compare 25 and 27. Okay. So these are already in sorted order. So we just simply increment the left. Okay. We just increment the left variable. Now we have to compare A left and ALOC. Is ALOC is greater than A left? Yes, they are in sorted order. They are already in ascending order. So no need to interchange. What we will do? We simply increment the left variable. We simply move towards the LOC. Right? Now left is pointing to the element 36 and LOC is pointing to the 27. Again we will compare the A left and ALOC. Here ALOC is 27 and A left is 36. They are in sorted order? No, they are not in ascending order and they are not sorted. So we have to interchange the A left and ALOC. Right? Interchange करेंगे हम इन दोनों को. So after interchanging, the position of LOC is also changed. Now LOC will be at the left. Okay, because in the previous working steps we discussed, when जब भी आप interchange करेंगे LOC की position भी change होगी. ठीक है, तो यहाँ पर हमने 36 and 27 को interchange किया. तो previously LOC आपका right पे था, तो after interchanging LOC अब आपका left पे होगा. Now LOC is at the left. So we will move from right to left. Now we have to compare 36 and 27. Are they are in sorted order? Yes, they are already sorted, so no need to interchange. So here we simply decrement the right variable, we have moved towards the LOC. Now again compare 27 and 18. A LOC is 27, A right is 18. So are they are in sorted order? No, they are not in sorted order. So we have to interchange these two elements. Also LOC will be changed. Now LOC will be at the right. Okay. Again compare A left and A LOC. They are already in sorted order. So we simply क्या करेंगे हम लोग? Just increment the left variable. Now when LOC लेफ्ट एंड राइट वेरिएबल जब भी आपके सेम पोजीशन पर रीच होंगे, ओके, व्हेन एलओसी विल इक्वल टू राइट एज वेल एज इट इज इक्वल टू लेफ्ट, देन इट मींस द पाइवोट एलिमेंट 27 is reached at its correct position. So after sorting this array, the 27 will be at the index 0, 1, 2, 3, it will be at index 4. So this is the correct position of pivot element. First iteration is completed, and after completion of first iteration, the pivot element is reached at its correct position. Now this array is divided into two parts, two sub-arrays. The left sub-array will have the elements 25, 10 and 18, and in the right sub-array we have the elements 36 and 45. So the elements in the right sub-array are greater than the pivot element 27, right? And the elements in the left sub-array are less than the value of the pivot. So now again we have to recursively sort these arrays, left sub-array and right sub-array. Again we have to choose the pivot element, again we have to initialize the left variable, right variable, and we have to compare. Initially we will compare 18 and 25. So 18 and 25, they are not in sorted order. So we have to interchange these two elements. 18 will be here, 25 will be here, right? And this is left, this is right, and हमने interchange किया. That's why LOC will be now at here. Initially LOC was at 25. Okay. Again we have to compare 18 and 25. Now they are sorted, so we simply increment the left variable. Again compare करेंगे, they are already sorted, so we simply increment the left variable. When LOC left and right will reach at the same position, it means pivot element 27 is reached at its final position. Now again we have to partition this array. Okay, in the left sub array we have two elements 18 and 10, and in the right part we don't have any element. Okay, same approach is followed here, so we have to recursively apply the same approach to sort the sub arrays until all elements are reached at their correct position. So this is the concept of quick sort. So this is the algorithm. So initially we have to partition the array. So quick sort, here we ARR represent the array begin, variable begin represent the first element, and the variable end represents the last element of the array. So in the step 1, first we have to compare the condition. If begin is less than the end, then we have to call the partition function. Okay, in which we are passing the parameters complete array ARR, the variable pointing the first element, that is begin, the variable pointing the last element and the pivot element which is chosen. So we have to pass these 4 parameters to the partition function: the pivot element, the position of the pivot element, the first element, last element. It means basically we are passing the size of the array, कि हमें complete n elements consider करने हैं, n-1 elements consider करने हैं, n-2. For the initially we are passing the complete array. Okay, and in the second iteration we will pass the left subarray and the right subarray. Again, we are calling the same function recursively to sort the subarrays. And this is the partition function. So वही है same. In the step 1 we are initializing the variables, but here we are using a new variable, that is flag. Flag variable we are using to basically to know the direction. We are moving from left to right direction or from right to left direction. We are scanning the elements from left to right or right to left. So when the flag is 0, flag 0 means pivot element is at the, जब भी आपका flag 0 होगा, it means pivot element, that is LOC, is at the left and we are moving from right to left. So these step 3 and 4 will be executed when flag is 0. Flag 0 means when pivot element is at the left and we are moving from right to left. And step 5 and 6 will be executed when the pivot element is at the right. Step 5 and 6 will be executed when flag equal to 1 and pivot element LOC is at the right and we are moving from left to right. So these step 5 and step 6 are representing the steps when our direction is from left to right, and step 3 and 4 will be executed when the pivot element is at the left and we are moving from right to left, and step 7 and 8 exit. Okay, and in these steps we are just comparing the elements. If there is a need of interchanging the elements, we are interchanging the elements. We are changing the position of LOC as well as we are changing the value of the flag. So this is a complexity. When worst case कब होगा, maximum running time कब execute आपका use होगा quick sort में, when we have the unbalanced partitions every time. Suppose after the first iteration we are partitioning or dividing the array, and elements को आप divide कर रहे हैं. In the left subarray you are getting 0 element and in the right subarray you are getting the n-1 elements, and after that iteration again you are getting 0 element in the left subarray and n-2 elements in the right subarray. Again you are getting 0 elements in the left subarray and n-3 elements in the right subarray. It means we are having the unbalanced partitions every time. So this is a worst case of the quick sort algorithm. So at this level the cost will be C of n. At this level the cost will be C of n-2, n-1. At this level you are getting the cost C into n-2. At this level you are getting the cost C of n-3, and at the last level there is no cost because we are having only one element, so there is no partitioning time taken, so that's why here cost is 0. So after summing of these cost values and solving this equation, you are getting the complexity is n square. So in the worst case you are getting complexity of big of n square, and this is the best case. Best case occurs when every time we are getting evenly balanced. It means in the left subarray we are getting n-2 elements and in the right subarray we are also getting n-2 elements. Again in the left subarray we are getting n/4 elements, here we are getting n/4 elements. It means that we are getting the equally partitions जब हो रहे हैं, ठीक है. The sizes of the subarrays are equal with each other or there is a difference of 1. So this is the best case, and here when we will sum all these cost values we are getting the complexity as big of n log n, which is similar to a merge sort, because merge sort में भी हम यही करते हैं, equally partitions करते हैं. Okay, so this is the best case and this is the average case. Average case means we are partitioning the n elements into 3:1. We are doing 3:1 split. It means in the left part we are getting n by 4 elements, in the right part we are getting 3 by 4 of n elements. Again, in the next step we are getting n by 16 elements in the left subarray, and in the right subarray we are getting 3 by 16 of n. So after summing these cost value, we are getting running time as big O and log n. This is the average case running time. So in the worst case, the time complexity is big O n square, but in the best and average case, we are getting complexity big O and log n. Okay. So at the last, these are the pros and cons of quicksort. It is basically a faster than other algorithms. Like if we are comparing it with bubble sort, selection sort, and insertion sort, this is more faster as compared to these sorting algorithm. And quicksort can be used to sort arrays of small size, medium size, as well as for large size arrays. But it is more complex and it is massively recursive, because every time we are partitioning the array and choosing the pivot element and solving these sub arrays, so it is more complex and recursive in nature. And the efficiency of the quicksort depends on the element which is chosen as the pivot. Okay. So depend करेगा कि आप pivot element किस element को choose कर रहे हैं. You are choosing the pivot as the first element or middle element or the last element. So its efficiency or running time depends upon the pivot element जो आप choose कर रहे हैं. And unlike merge sort, it doesn't needs any additional space. It is basically a in place sorting algorithm which sorts the elements at their original memory locations. You do not need any extra space or additional space to sort the elements. Okay, this is all about quicksort. Thank you.